So this, whenever we have mainly 4 terms, we have a total of 4 terms: x power 3, negative 8x squared, 3x, and negative 24. And we want to find the value of x, and we're unable to do so with a calculator or something, or if we're not allowed a calculator, what should we do? So you group. This method is called grouping, and it's called grouping because you group the first 2 terms together, and then you group the second 2 terms together. So أول 2 terms, I'll just put them in brackets, that's all. Here they are in brackets. And you always put a plus sign, and then you open another bracket and you put the other 2 terms. So again, what I did here is I just grouped them, the first 2 terms in a bracket and the second 2 terms in another bracket. Okay, what happens next? We do something called a common factor. What is a common factor? We look at these 2 terms. ايه الcommon ما بين x power 3 و 8x power 2? What's common and available in both of them? It's x to the power of 2. Yes, the smaller power هو ده اللي common ما بين الاثنين. So لما يبقى عندي مثلا x power 4 و x power 2، ال x power 2 هي ال common ما بين الاثنين. عندي x power 5 و x power 3، ال x power 3 هي اللي common ما بين الاثنين. In this case x power 2 is common ما بين الاثنين. طيب what happens next؟ ال x power 3 خدت منها x power 2. The remaining is just 1x. هما كانوا 3x's x power 3. أنا خدت منها 2. هيتبقى 1x only. طيب this one كانت negative 8x power 2، خدت منها x، يتبقى negative 8. This is the first part. Plus. Now التاني برضو عايز أعمل فيه common factor. إيه ال common ما بين الاثنين؟ ال 3. Because I can divide both by 3. If I divided ال 3x by 3 هيتبقى x. طب ال 24 بعملها divided 3 مش minus 3. divided 3 تطلع لي برضو 8. The bracket equals to 0. Until this step, anyone has any troubles, any problems? Sure, everyone? طيب, what happens next? برضو باخد common factor. يعني هشوف what's common between these two دلوقتي. This x plus 8 is common here and there. في البراكت كله x minus 8 موجود common ما بين الاثنين. So لو أنا خدت ال x minus 8 دي نفسها as a common factor بره وافتح براكت تاني هيتبقى إيه؟ هيتبقى لو انا خدت الاكس ماينس 8 دي هيتبقى اكس باور 2. لو انا خدت الاكس ماينس 8 دي هيتبقى 3. يبقى احط اكس باور 2 بلس 3 كلوز ذا براكت. دلوقتي بقى عندي 2 براكتس تايمز بعض ايكوالز تو 0. اول ما اوصل للمرحله دي بقول يا اما الاولاني هو اللي ايكوالز تو 0 يا اما الثاني هو اللي ايكوالز تو 0 واحاول احل. This one x will come out as 8. This one x power 2 will become negative 3. And I cannot get the square root of a negative number. So therefore هنا خلاص it stopped. This one is undefined. It's non-applicable. So the final answer in this case is just x equals 8. Does that make sense? Everyone? Awesome. طيب. سؤال تاني جاي ثاني. محمد جلال. احنا بعدين حاجة تانية صح؟ السؤالين ولا سؤال واحد عايزه؟ لا خلاص معانا نفس التاني اسهل. بس لا التاني ماشي هقول ماشي. طيب اللي بعدها كان محمد جلال. انت بعت لي نفس السؤال. ايه ده خلاص. ايوه السؤال اللي بعده اصل انا اسلام حل ده حل نفس الطريقه كده بس جبت بقى اكس اللي هي سكوير ما عادش. No. The other one يا حبيبي it says ان انا عندي x to the power of 2 sorry x to the power بيقول لي x is bigger than 0 معناها ايه؟ قلنا اول ما اشوف في الاس تي تي او في البي اس تي او في الاي سي تي اي حاجه بتقول x bigger than 0 او حاجه اكبر من 0 او اصغر من 0 the only information or the only reason they're telling me this is to know whether it's positive or negative. So since it's bigger than 0 then it's positive. I do not substitute x with 0 او ب 1 او ب 2 مش بقعد اجرب ارقام لا بس انا المعلومه دي كل لازمه الحته دي ايه؟ انه يقول لي ان الحاجه دي positive ولا negative وخلاص. Then بيقول لي what is one of the solutions of x power 4 minus 8x power 2 equals 9 and you need here to find the value of x. دلوقتي يا محمد لما تبص عليها قلت لك لما يكون عندي اي حاجه اكبر من x power 1 بنموف كل حاجه في ناحيه واحده and we make it equals to 0. So I move this line to the other side just to make everything equals to 0. لما اجي ابص دلوقتي how many terms are there? There's 1 2 3 terms. They're not 4 terms. So here grouping does not work. الجروبنج لازم عندي 2 و2 دي كوادراتيك بس شبه الكوادراتيك هي مش كوادراتيك هي مش اكس باور 2 دي اكس باور 4 طيب هعمل ايه؟ هحلها كانها اكس باور 2 بص على اللقطه اللي هعملها دلوقتي اوكي بدل اكس باور 4 I write اكس باور 2 بس all to the power of 2 minus 8 وبدل اكس باور 2 احط اكس و all to the power of سوري اكس باور 2 برضه ومن غير باور وماينس 9 و all equals 2 ليه عملت كده؟ It's as if دلوقتي as if it is x اهي كأن دي كلها x power 2 minus 8x minus 9 ازاي اعمل لها factorization؟ I should open up two brackets if you remember and I'll put here x و x واشوف رقمين times بعض يدوني 9 and plus or minus يدوني 8 the only two numbers that could do so are 1 and 9 بالظبط we said the bigger number takes the middle sign so this one is the negative because this is negative then these two must be different signs so this one must be plus صح؟ الفكرة بقى انها مش x هي x باور 2 هو ده الفرق اللي ما بين الاكس باور 4 واكس باور 2 رقم واكس باور 2 واكس باور 1 ورقم سو كانك بالظبط عملت نفس الستبس بس اللي انت طلعته مش الاكس اللي انت طلعته دي اكس باور 2 فتطلع لي هنا اكس باور 2 equals negative 1 وهنا اكس باور 2 equals positive 9 does that make sense؟ دي هتطلع لي دي هتطلع لي لا دي هتطلع لي non applicable undefined لان ما ينفعش اعمل سكوير روت للنيجاتيف بس هنا ينفع اعمل سكوير روت لل9 هيطلع لي positive or negative 3 so there are two answers here that works x equals 3 and x equals negative 3 those are the two solutions for x هو فوق خالص قال لي ان الاكس must be positive must be bigger than 0 so I have to take the x equals 3 and discard completely the other one makes sense everyone else does that make sense as well جاد عندك ايه اسئله عن نفس الحاجه
مثلا في حتة مفهمتهاش هو ال x equals negative 3 دي أنت قلت لأ ليه؟
عشان هو فوق خالص if you remember the first thing we read في الكويستشن كانت ان الاكس bigger than 0 so this means الاكس must be positive الاكس النيجاتيف كده ما تنفعش طيب ماشي جد هخليني اظبط معاك مره نقعد نشرح الحاجات دي احسن طيب اخيرا عايز بقى ابتدي شويه معاكم الجيومتري I want you please to focus شويه فيهم they're extremely important ال questions of the geometry عيبهم they're not hard او ال hard part فيهم is the fact that they're relating too many things with each other يعني مش بس هيبقى الرول ده لوحده ولا الرول ده لوحده دايما السؤال بيكون فيه more than one rule اوكي طيب and we'll start from the basics خالص and move forward so the geometry starts with lines and we'll have, let's say, two lines that intersect each other. Yes, yeah, Jed, of course. Some formulas, very basic formulas, are given in the test, others are not. We try not to refer to the formulas اللي في التست لأن this would actually فعلا waste time. You moving forward or moving from the first of the page that you're working on to the first page just to remember a tiny rule that's already a basic doesn't make sense. Volumes and areas are provided. I will teach you a trick in order to know all the rules for volumes and areas for any shape whatsoever. So just bear with me and we'll see. So mainly we started, as I said, with two lines that intersect. Now whenever an X shape كده is formed, the two opposite angles are equal to each other. So if this is the measure of this one is A, this one will be A as well. And this is what we call vertically opposite angles. So whenever two lines intersect, they form an X shape, and that X shape consists of four angles mainly. The opposite angles to each other are equal to each other. Vertical Yeah, it's not vertically opposite angles. It is the vertically angled theorem, okay? But it's not, yes, it is anyway. So if this one, let's say, was equals to this one, is equals to B, برضو because this one is opposite to it, it must be equals to B as well. Type, how does this work, and what an example to this one? For example, if I told you that this angle is 120 degrees, so definitely this angle as well is 120 degrees. Now what about the value of B? So any line in the world creates something called a straight angle. A straight angle is mainly this entire yellow angle. It's like an angle that's stretched until it became a line. The angle D is equals to, this straight angle is equals to 180 degrees. So any line in the world has a straight angle. The angles right.
هو مستر بس
Yes.
أنا آسف مستر
لا
قاطع
لا
هو في الفيرتيكال أوبوزيت أنجلز حاجة اسمها كونفكس هو كونفكس أو تير حاجة كده
لا خالص.
عشان
never
كان
mind.
بيجيبوها وأنا مبقاش عارف مش فاهم أصلا.
not at all. لا فين السؤال ده؟ مفيش كده. لا يبقى مش بيتحل بالطريقه اللي انت بتفكر بيها، دي بيتحل بطريقه ثانيه برضه، فاهم؟ خليني اوري، يعني انت لو متهيأ لك ان this is the only way to solve the question بالtheorem اللي انت بتقولها، that's not true because it could be solved with another theorem. انت بس you thought ان this is the only way to solve it، فاهم؟ بس this theory اللي انت بتتكلم عليها is not ever part of any of the questions that was there. يعني not with ميزه الجيومتري وعيبها في نفس الوقت ان على قد ما هم فيها 600,000 رول، على قد ما هم كلهم على بعض درايف من 3 4 رولز مثلا من رول. فانت يا اما هتقعد تحفظ 60,000 رول which would to be honest is a bit stupid، او انك تحفظ لك الخمسه سته دول وتطلع منهم الباقي اللي انت عايزه. this is what shows شويه differences ما بين حد بقى ايه بيخلص حاجات بسرعه وبيريليت الحاجات دي ببعضها ولا لا. انت ممكن تبقى حافظ ال 20 ومش عارف ان الاول 10 كلهم ليهم اي علاقه ببعض او ان انا ينفع ايوز them with each other، فاهم؟
أيوه
بس فيعني ده برضو معايا هفهمك الموضوع خالص. انا بتكلم يا جماعه very simple as if you don't know anything. So يعني try to think about it as if برضو you don't know anything and you're trying to build من الاول. If in this case as I'm saying انا عندي اي line في الدنيا will have something called a straight angle. This entire angle اللي هي A B على بعض A plus B على بعض. This is what we call a straight angle. So أي line عليه نفس الكلام ده which means لو دي straight angle اللي تحتها كمان ال A و B اللي تحت كمان هيعملوا لي 180. طيب يعني what does that mean؟ لو أنا بتكلم على 2A و 2B، يعني لو بتكلم على the whole thing، ال A دول الاثنين بلس بعض وال B دول بلس بعض هتبقى 180 180 اللي هي 360. So this is the reason why an entire circle is considered 360 degrees. If I started from here, went around the whole thing and came back to the same point, this is 360 degrees. طيب once we move from two lines that intersect, we move to three lines that intersect. And once something like that happens, no, Jed, just bear with me. Stop asking about things, يا جماعة. This will confuse you even more at this step. I will lead you to take everything and to know everything about it, but just swirl, okay? So again, moving from two lines that intersect to three lines now that intersect. Once something, no need to resolve. Once something like that happens, there are three angles that are created. Those three angles inside the triangle. Keep in mind, or remember, they are inside the triangle. Those three angles, A, B, and C, the three of them are to us called interior angles because they are inside the triangle. Again, interior angles are angles inside the triangle. The sum of the interior angles of any triangle in the world is 180 degrees. So as long as we're talking about a three-sided shape, a triangle, we are going to know that the sum of the angles is 180. Sum of the interior angle is 180. If I increase the number of sides, if they became 4 sides, for example, there is another total or another sum that's there. Another sum or case. So imagine if I have now, instead of 3 lines, 4 lines that intersect. So they form some sort of a rectangle, yes, or a square. In this case, the 4 angles that are available inside, the sum of them will become 360. So what if we have 5 lines that now intersect? What would be the sum of their interior angles, A, B, C, D, and E? So there is a rule to know the sum of the interior angles, to know the sum of the interior angles of any shape, depending entirely on the number of sides. So if you know the number of sides, you can use this rule to get the total sum of all the angles inside that shape. What's that rule? It's n minus 2 times 180. This is the rule. N here represents the number of sides. So if you know that this shape consists of 4 sides, for example, like a rectangle, you just do 4 minus 2 and multiply that by 180. This will get me 360, which is the sum of the interior angles of any 4-sided shape. Does that make sense until this point? Everyone? Of course.
4 minus 2 brackets and 180.
The rule says if I have any number of sides of a shape and I would like to know the sum of the interior angles of that shape, I should put n with the number of sides. So I said, for example, if I know that the shape has 4 sides, I'll substitute the n with 4 in this case. So this is an example application of the rule.
I got. So basically, 4 minus 2 is basically 360 minus 180.
No, 4 minus 2 is 2. So then 2 times 180 would result to 360. So now I got the total or the sum of the interior angles of a 4-sided shape. Any 4-sided shape, and by that I mean a square, a parallelogram, a quadrilateral, a rectangle, a rhombus, any shape with 4 sides.
So this only applies to 4 sides, right?
Yeah. Ali, focus ya habibi. N is the number of sides. No matter what are the number of sides, you substitute n with that number. So if I say, for example, we have now 5 sides, like a pentagon, how would I know what's the measure of A plus B plus C plus D plus E? I use the rule. I'll substitute now 5 minus 2 times 180. That would give me 3 multiplied by 180. That would give me 540, sorry. So then now I know that the sum of the interior angles of a pentagon, which consists of 5 sides, would be equals to 520. Does that make sense?
Yes.
Are you sure?
Yes, I got.
Right.
Thank you.
Most welcome. Now, we're all now discussing just the interior angles of any shape whatsoever. So let's get back to the triangle because it's the most important. Imagine, for example, if I know that this angle is 30 degrees and I know that this B is 100 degrees, How would I know the value of C? I'll use that theory of the sum of the interior angles. I'll say that 180, which is the total of the three angles, هشيل منها, I'll remove from it the A, which is 30, and I'll remove from it the B, which is 100. That would leave me with the C, which will be equals to 50 degrees. You all now know how to use the sum of the interior angles, or when to use them. Perfect. So what about then the angles that are not interior? Yani what if we're talking about a triangle like this one, and now instead of talking about the A, B, and C, which are the interior angles, what if we're talking about the ones that are outside? For example, this one here. Or this one here. Or that one. So let's give those letters. Let's give this one X, this one Y, and this one Z. Out of the first rule we've taken, which is the vertically opposite angles, if this is Z, the one right in front of it should be Z as well. No, wait, yeah, Jed, please. If this is X, the one right in front of them will be X, which is equivalent as well. If this is Y, the one right in front of them is Y as well. So A, B, and C are considered interior because they are inside the triangle, while X, Y, and Z are considered exterior because they're outside of the triangle. There are, though, these. This one here, the blue ones. What are those called? They are outside of the triangle, but they're equivalent to the interior. يعني كده كده this one is equals to A like this one, or this one is equals to C like this one, this one is equals to B like this one. So even though they're outside of the triangle, we consider them interior because they're equal to the ones that are interior. طيب, what is the sum of the exterior angles of any shape, not just the triangle? The sum of the exterior angles of any shape in the world is 360. It's constant, 360. Whether they are this is a triangle or a pentagon or a hexagon, whatever the number of sides and the number of angles, the exterior angles together must be equal to 360. Does that make sense?
مستر سؤال.
Yes.
360 اللي هم هيبقوا 3 منهم.
يس انه اكيد مش الواي مرتين ولا الزد مرتين، يعني هاخد الاكس مره يعني فاهم، يعني مش هعيد اي واحد منهم مرتين. So just one x with one y with one z, x plus y plus z should be equals to 360. That is what it means. Okay. Right. So there is an exterior angle theorem. There is a theory that works for the exterior angle. What is that theorem? So, for example, if you have a triangle like this one and you know that this angle is 30 degrees, you know that this one is 50 degrees, and you'd like to know the measure of this angle, the x. The exterior angle theorem says if you need to know the measure of one of the exterior angles, just like x, you just need to add the other two angles that are interior and they're not next to the x. Let me repeat الكلام ده. يعني هتروح ما دام انا عايز واحده exterior يبقى هروح inside the triangle first of all وهاخد ال two angles اللي مش جنبها. So leave this one and take the other two, which are 30 and 50. That should be the value of the exterior angle. So mainly the exterior angle theorem says that if you have, let's say, y, المفروض تبقى equal للاثنين اللي مش جنبها اللي هما A and B plus بعض. On the other hand, if I want x, let's say, which is this one, it should be equal للاثنين اللي مش جنبها اللي هما A and C. If I want z, هسيب اللي جنبها برضو اللي هي ال A واخد ال B وال C plus بعض. Does that make sense? It always works, yes, it did. And can you show an example? I will. And this step, does that make sense? طيب, how can we use this in a much harder, or in a bit of a harder way? How can we see a question about something like this? It give you something like that. They tell you this one is x plus 10, this one is 2x minus 30, and this one is x plus 4. You're asked to find the value of x, not x, yeah, actually 2x plus 20. So how do I find the value of x? First of all, you look, is this an exterior? Yes, it is an exterior. What does the rule say? الرول بيقول المفروض you take the exterior angle and it should be equal to الاثنين اللي مش جنبها plus بعض, which are x plus 10 plus 2x minus 30. Now start solving the equation. So move all the x's on one side and the numbers on the other side and so on. You have here negative 20. You have here 3x, adding like terms. Then I'll move the 2x towards the 3x and the negative 20 over there. So x will be equals to 40. This is the value of x. If they wanted me to find the value of this angle specifically, I would have substituted x with 40 plus 10, for example. If I wanted the other one, it would be 40 times 2 minus 30, and so on. Makes sense? Yes or no?
Mister, I get the equation, you get how to do it, but I'm just confused, like, because when you solved it, you did it a bit faster, so I just want to know how you got 2x plus 20 plus 3x.
لا, ask, not how they get it there. So look at the step. I can't طبعا tell you. I know. Just look at the first equation right before. What should I do next? لما يكون عندي 2x plus 20 equals to x plus 10 plus 2x minus 30, which is this step here. What should happen next in order to find the value of x? يعني, what do you think?
The other side.
I'm sorry? I'm sorry, your voice was lagging. Can you repeat it again?
Substitute it to the other side for the like terms.
The word substitute means to remove the x and put a number, or to put something instead of the x. So you mean to move x to the other side? 2x to the other side?
Yes.
Okay, so our final target is to put the x's on one side and the numbers on one side. Is that true or no?
Yes.
So look at this. I added the like terms. I have this x and this 2x, and they became 3x together. I also have this positive 10, this negative 30. Add them together and they become negative 20. Then I moved this 2x towards the 3x by subtraction. So 3x minus x became just an x. And then I moved this negative 20 to the other side by addition. So it became 20 plus 20, which is 40. Are you sure?
Yes. So basically, you just move 2 to the other side, but the sign changed. So it's 3 minus 2, which is 1x, which is x. Then you took plus 20. You took it to the other side and you changed the sign. And you
I actually took the negative 20 to the other side. The arrows are there. The arrows would show you which one moved which direction.
so what?
Perfect. Now, طيب, the most welcome. So we now mainly discussed the ideas of exterior and interior angles. But what happens next? Because we started discussing triangles, triangles are the most important shape in geometry. There are types of triangles and there are rules that applies to each type. The first type is what we call an isosceles triangle. And an isosceles triangle is any triangle that has two sides that are equal to each other. Only two sides that are equal to each other. And because there are two sides equal to each other, there will be two angles that are equal as well. So which two angles? The ones right in front of the two equal sides. So if you look at those sides, الangles اللي بص عليهم are the ones that are equal. Good. How is this used? It's either that they would give you a triangle and they would tell you that this is 40 and this is 40, and you would deduct out of this that this side must be equals to that one. Or that they would tell you from the very beginning that this side is 5 and this side is 5 and this angle is 30, for example, and you're trying to find the measures of these two. How would you do so? You'll do 180 minus the 30, and then whatever comes out is divided into 2 because you know that these two are equal to each other because these two sides are equal to each other. That would give you 75 as the answer to each. What else? What's the second type of a triangle? One that's called a scalene or scalene triangle, however you'd like to pronounce it. A scalene triangle is a side or is a triangle with no equal sides or angles, of course. No equal sides or angles at all. كل sides مختلفة عن بعضها. مفيش واحد زي التاني. There is also an equilateral and mainly an equilateral triangle is a triangle with three sides that are equal to each other. So the three sides are equal. What does that mean when the three sides are equal? It means that the three angles as well are equal. So what's the measure of one angle of those? You just do 180 divide by 3 and that would give you 60. So now it became a well-known fact that whenever we see a triangle and we say that it's an equilateral triangle, this will mean right away that each angle is equal to 60. أو لو أنا اديتك triangle وأنت شفت إن already two angles of them are equals to 60, the third must be equals to 60, and that means that the triangle altogether is equilateral. Does that make sense until this point? Awesome. Finally, we discuss the biggest one, the right triangle. Okay, so the rules coming next all apply only on a right triangle. And a right triangle is any triangle that has one angle that's equals to 90 degrees, which is this one. So this symbol here of a box كده represents that this angle is equals to 90 degrees. Good. We could have an equilateral triangle that is an isosceles at the same time. So we could have a triangle where this angle side and this side are equal to each other. In that case, this angle and this angle will be equal to each other as well. So there could be an isosceles equal triangle. Sorry, an isosceles right triangle. But there can't be an equilateral right, because equilateral means we must have all three angles equals to 60. You don't need to know anything about the acute and the obtuse triangle within. There's no need to know what they mean. That's why I did not explain them. So bear with me in how I move through the curriculum itself. I know there are lots of topics available in geometry. It's a huge book with huge applications. Yet the parts that are important and the parts that we care about in the test, the ones that you can build on an understanding, are the ones that I select. So I don't want you to get involved in things that doesn't make any sense. The name of the triangle, whether it's obtuse or acute, does not really give you any information except that one of the angles is obtuse or the three angles are acute. Still, that wouldn't matter. But on the other hand, knowing that the triangle has a 90 degree and that this is called the right triangle is extremely important information, because specific rules doesn't apply except in right triangle. Anyway, so what kind of rules apply in right triangles? The first and most important one is the Pythagoras theorem or the Pythagorean theorem. The Pythagorean theorem is extremely important just to know, first of all, when to use the Pythagorean theorem. We use the Pythagorean theorem whenever we have two given sides. So we're talking only about sides now. Okay? Two given sides and one missing side. So the Pythagorean theorem does not depend at all, or does not use at all the angle. They just use sides, only sides. What does the Pythagoras theorem says? It says that the side in front of the 90 degrees, which we call the hypotenuse, is supposed to be equal to the lengths of the other two legs squared as well. This is the rule. برضو, how is this useful? So instead of this rule, deriving out of this rule, we got two other rules that are important. It depends on the hypotenuse. If the hypotenuse is given and you need to know one other side, there is a rule that should be done. If the hypotenuse is unknown and you need to know the value of the hypotenuse itself, that's another case. If you need to know the value of the hypotenuse, just add the other two legs squared. If you already know the hypotenuse, just subtract from the hypotenuse squared the other leg squared. Let's see example. Look at this triangle. You're given here that this side is 5. You're given here that this side is 3, and you don't know the measure of the third side. Apparently, because you are given two sides and you want one side, the Pythagorean theory is okay to use. I should do what? I should do the hypotenuse itself squared minus the other leg squared because the hypotenuse is given. All of this under square root, and it will get me the answer right away as 4. On the other hand, if I have a triangle like this one, and I know that this side is 6, this side is 8, and I don't know the measure of the hypotenuse. Since the hypotenuse is unknown, I should add both of the sides squared under the square root, and it will give me the answer right away as 10. Then the result of the measure of x in this case, 10. So two cases of the Pythagorean theorem derived out of one specific rule. Please confirm that you do understand everything regarding Pythagoras and when to use it.
Mr. Ahmed, I have a question.
Of course.
I understand everything. I just want to know, does it matter of the order of what is L1 and what is L2? And just put it in.
As long as you're talking about the legs, it doesn't matter. What matters is if you have the hypotenuse, because then you subtract. If you're adding, it doesn't matter which one goes first. Huh?
Yeah, and if you don't have the hypotenuse, for example, here there's 8 and 6. Does it matter if you do 6 plus 8 or 8 plus?
That's what I'm telling you. We're adding, so it doesn't really matter. Only matters if we subtract, which is the case whenever we have the hypotenuse, because the hypotenuse is the biggest actual side. We should start with the hypotenuse minus AB. If we don't have the hypotenuse, we just add everything that's there, no matter what's the result.
Thank you very much.
Everyone else clear regarding this? There is another part, another theorem, another rule that works here, but it relates angles with the sides, not just sides. So, which is mainly trigonometry. So trigonometry works only in right triangles, and trigonometry, by that I mean the sine, cosine, and tan. They only again apply in right triangles. So what are those? First of all, we agreed that the side right in front of the hypotenuse, right in front of the 90 degrees is called the hypotenuse, and it's the most important side of any right triangle. So what are the sines, cosines, and tans? They are a ratio. What does that mean, ratio? A sine is the division of two specific sides in a triangle. And the sine, cosine, and the tan, they have to be of an angle. يعني مفيش حاجة اسمها sine لوحدها. It has to be sine something, sine an angle, cosine an angle, tan an angle. This symbol here represents an angle, no matter what angle we're talking about. So mainly what you need to memorize is that sine any angle is supposed to be equals to the opposite over the hypotenuse. These are things that must be unfortunately memorized. So the opposite over the hypotenuse. While the cosine of any angle is equals to the adjacent over the hypotenuse. And the tan of any angle is equals to opposite over adjacent. You can remember those through acronyms. acronyms that goes this way. So, وكا, وتوا. So S stands for sine. It takes O opposite over H hypotenuse. C stands for cosine, for adjacent over hypotenuse. Tan opposite over A, which is the adjacent. This is how you can memorize them. Right? When do we use them? How do we use them? Or why do we use them? We use them whenever we need to relate two sides of a right triangle and one angle. So whenever we're now talking not just about sides anymore, we're talking about sides and an angle. We're trying to relate between them, or you're given a side and an angle and you'd like to find the third side, the second side, or if you're given an angle, or if you're given two sides and you'd like to find an angle. So whenever angles or sides are included in the same question in a right triangle, we're probably talking sine, cosine, and tan. So how can we use it? Look at this. If you have a right triangle like this one and you have this angle, let's say we're talking about this angle here. So A, B, and C. We're talking about angle C. You're told that this is 5. Never mind what measures. If I ask you for the sine of angle theta now, which is angle C, which side is opposite to angle C? You go to draw an arrow and look, where does this angle look to? It looks to this side, which is called AB. So this is what we consider the opposite. Over the hypotenuse. Which one is the hypotenuse? The one in front of the 90, which is the AC. So then sine theta is equals to AB over AC. If we're talking on the other hand of cosine, cosine should be the adjacent. What's the side right next to this angle? Adjacent يعني next to. It could be either AC or BC, but AC we know for a fact that it's called the hypotenuse. So definitely this is the one that's considered the adjacent. So it's actually BC over the hypotenuse, which is AC. Type. What if I decided to talk about the other angle, this angle here, X? So now if I said sine X, which side is the opposite to X? It's this one now, BC. Which side is the hypotenuse? It's still AC. So the word opposite and adjacent depends entirely on the angle. Which angle are you talking about? لو بتتكلم عن الانجل اللي تحت, which side is the opposite to? لو بتتكلم عن الانجل اللي فوق, which side is opposite to? The only thing that never changes is the hypotenuse. It will remain to be called hypotenuse no matter the angle we're talking about. Does that make sense? Good. So how again? Yes. Yes.
هو اللي هو اللي احنا خدناه اللي هما كانوا ساين equals 1 over مش عارف ايه الكلام ده بيجي
ايش
مش عارف بس يعني مش عارف
ساين لو؟
لا اللي هو ساين equals 1 over cosecant
في الستاندردايز تيست لا. اللي هم الانفيسز اسمهم. لا. We can يا احمد يا محمد definitely say so. Identities are not included here. Just simple basic terms or fine for them. There's a theory though that matters قوي معايا. If I continue with this example, I said that cosine x should be adjacent over hypotenuse. The adjacent in this case is AB over the hypotenuse, which is AC. Now, what's extremely important for me for you to understand is this part here. Look at this. Cosine x was equals to AB over AC, while sine theta, sine, not the cosine, sine of theta, was equals to the same value, which is AB over AC button. So what does that say? It says that whenever, please focus before the, whenever we say that sine one angle is equal to cosine another angle, these two angles together added would be equals to 90 degrees. definitely. This is an important rule, an extremely important rule. Whenever sine and cosine are equal, this means that the angles we're talking about are plus بعض equals to 90. Because if you look at this example here, sine theta, which is this, or cosine x, which is this, is equal to each other. And if you look at x and theta plus بعض, they must be equals to 90 because the three angles together are 90. Does that part make sense?
مستر هي دي نفس الرول اللي هي sin equals cosine 90 minus x.
True. بس دي
هي جت امبارح
بنستخدمها.
فأنا حاول أفهمها
لا، ما دي جات لك في ايه؟
في امتحان.
جات لك ان ساين انجل ايكوالز تو ساين انجل ثانيه وخلاص، والاثنين فيهم اكسز، صح؟
لا قال لي sin x equals 0.50 حاجة
ماشي.
وبعدين قال لي
كوزاين اكس ماينس 90.
ايوه 90 minus x.
Exactly.
فأنا كنت عارف إن هم equal.
They are. ما that's بقى هو بس البوينت، الاثنين يبقوا ايكوال بعض. I will يا لينا طبعا. So for example, يا لينا, imagine if I have sine any angle, let's say x plus 3, and I told you that sine x plus 3 is equals to 50. أو لا ما ينفعش. 0.7. Now, if I told you that cosine 2x minus 10 is equals to 0.7 as well, what does that tell you? It tells you that the angles, these two angles, which is this and that, because the sine and the cosine are equal, then the angles added to each other should be equals to 90. And you can solve this way and find the value of x and say that 3x minus 7 is equals to 90, which then means that 3x is equals to 97, which then that means that 97 over 3 is the value of x. This is one way, another type of question that could be there. Another question he could tell you that, let's say sine A, sine A, yes, let's say is equals to 0.7, and then they're asking you what is the value of cosine 90 minus A. So A and 90 minus A means you're talking about the two angles in the right triangle that are not 90. يعني لما أقول لك A and 90 minus A, then I'm talking about these two angles, this one and that one. Because if the first one is 30, the other one would be 90 minus 30. So if the first one is A, the other one would be 90 minus A as well. So when they tell you, for example, that sine one angle is equal to sine A and then cosine 90 minus A, what's the value of the cosine 90 minus A? They're equal to each other. Because you know that sine one angle is equal to cosine the other angle if both angles added would be equals to 90. And that's the case here. This angle plus this angle would be equals to 90. So therefore, the sine and cosine are equal to each other. Does that make sense شوية لينا ولا لا؟ Sure, huh? طيب, what else is there regarding this the trigonometric? Oh, that's why I never got. Okay. So you got this part, yeah, that's huh? Yes, Jed, it's true. You memorized the identity. Oh, you memorized the trigonometric functions. You memorized that sine 30 is half and sine 60 is half. This is a proof of this the theory. Because the sine and the cosine here are still both equals to half, this means that the angles must be equals to 90. And once you look at them, 30 and 60 are actually equal to 90. So that's true. So anyway, we just moved from the idea of two sides and one side. So we're talking just about sides. Now we're talking just about angles. Sorry, just about sides and angles. We're linking sides and angles.
حاجة على حتة الإيكويشن دي.
This one.
أيوه.
So again, لو انا قلت لك ساين انجل اهي طلعت ب 0.7 وكوساين انجل ثانيه بنفس الفاليو. What does that say about the angles, يا عمر? That they're added to each other must be equals to 90. So I did add them and I made them equals to 90. Then I solved for the value of x. ماشي. Sure? ماشي. طيب. The third part is whenever we do have now angles and only, not only angles, we can't have only angles, but يعني we can, لا خلاص just never mind the third part. Right, what else do we need to know? Oh, okay. So what if we now have a triangle that's not a right triangle, not a right triangle, and we do know that the measures of its angle, but we would like to know, according to those measures, what's the order of the sides? Like which of those is the biggest side, not an angle. So the biggest side is right in front of the biggest angle. So since this is the biggest angle, the 130, the side in front of it, which is AC, must be the biggest side. The one right less than this is the one, or smaller, sorry, is this one, which is AB. And then the smallest side would be the one in front of the smallest angle. So then that's BC. And the same idea works the other way around. So if I know the measures of the sides, I can order the angles from biggest to smallest or smallest to biggest using the same theory. Does this part as well make sense?
مستريح من ترفع سنة. أيوه سنة.
ماشي. طيب, moving on from all of these to areas and volumes. So the following rules apply on any shape whatsoever, and we start with the areas. Okay, so the area of any shape in the world is basically base times height. And when we're talking area, we're talking about things that are 2D, like a square or circle or triangle. An area is the space that this thing is taking on a sheet. So why is it then that we've heard so many different rules? It's because the names of the base and the height change depending on the shape. For example, if we're talking about this rectangle, where is the base of the rectangle? This side here could be considered the base of the rectangle. And where's the height then? The height and the base must be perpendicular on each other. They must create a 90-degree angle. So therefore, this one is considered the height. But in any rectangle in the world, we call the taller side the length, and the shorter side, we call it usually the width. And that's the reason why that the area is supposed to be base times height, but the name changed. It became L times W, length times width. But again, the idea of it is just base times height. If you think of a square, now a square is tricky because all of the sides of the square are equal to each other. But when you look at this side, for example, this may be considered the base, and if this is the base, this one could be considered the height. But since all the sides of a square have equal measures, this one we call it a side, and that one we call it a side as well. So the area of a square becomes side times side, which is mainly side squared, and that's how we got this rule, side squared. The only thing that changed this rule a bit is the triangle, because the triangle, when you look at it, where's the base of the triangle? This could be considered the base. Where's the height of the triangle? This could be considered the height. But the area of the triangle is half times base times height. Why is it half times base times height? Even though I said that all shapes should have an area of base times height. It's because the triangle is mainly half a square. And a square has an area of base times height. The triangle is half of that. So that's half times base times height. And that's how where this rule came from. Does that make sense? The three of them. Right? Then we talk about the circle. The circle has a very special rule for the area and a very special rule for something else called the circumference. The area of the circle is this region here, and the area must be, or I cannot actually get the area or the circumference unless I have the radius. The radius is the measure from the center of the circle until the circumference of the circle. So what's the circumference? The circumference is this line that's rotating around. The edges of the circle itself is what we call the circumference. The length of this edge is what we call the circumference. So the area is mainly pi times r, which is the radius, to the power of 2, while the circumference is 2 times pi times r. The pi only exists whenever we're talking about circle. So these must be just memorized, and they do not apply. The circle does not apply these rules for it because it doesn't have a base and it doesn't have a height. Makes sense. Then if we move to the idea of volumes, what's the difference between a volume and an area? The volume is for a shape that's 3D. It's a shape that actually has a size. It takes up space in a room. That's what we call a volume. And these are the things that has volume. So the volume of any shape whatsoever is the area of base multiplied then by the height. And why is it area? Why is it just not base? Area? Because the shapes, as I told you, are 3D shapes. So when you look, for example, at a cylinder has a base of it. The base is not a line. The base is a circle. It's a shape. So we need to get the area of that base and then multiply that by the height. So the area of the base here, since it's a circle, it's pi r squared. This is the area of base. Now multiply that by the height. What's the height of the shape? It's h. So this rule is the volume of the cylinder. If you're talking about a rectangular block has a base of the shape of a rectangle. Now what's the area of the base then? Length times width. This is the area of the base. Multiplied by the height of the shape, which is this side or that side or this one or this one. These are the h. Then you get the volume. Finally, if we're talking about volumes of shapes that has peaks, like for example the cone or the pyramid, these shapes are tricky because they have a base of a circle, but they do not continue till the end. They actually have a peak like this. Same thing for a pyramid. A pyramid could be based of a square, could be based of a triangle, could be based of anything. So whenever something like that works, something has a peak, nivus, it's the exact same rule for the volume, area of the base multiplied by the height, but we just multiply by 1 over 3. So the area or the volume of this would be 1 over 3 multiplied by area of base multiplied by the height. In this case, the base of it is a circle, so the area of the base is pi r squared. Multiply that by the height, which is this height here. Multiply that by 1 over 3, and you got the volume of the cone. Same thing applies to a pyramid with a square base. The area of the base is side times side. That's the base of the area. Now multiply that by the height, which is a dotted line here. Multiply that by 1 over 3, and you've got the volume of the pyramid. Everything so far makes sense.
Mr. Ahmed, can you go up?
بالظبط هو ايه انا كنت فاكر لما خدت السنه دي كان في حاجه اسمها سلانت هايت تقريبا.
Slant height is this height. So if you're talking about a pyramid, a cone like this one, the slant height is this side, the side المعوج ده. But that's not important at all in the EST or the SET or the ACT. The only if something like that exists, we deal with it as a triangle. We don't deal with it as a cone, and I'll show you questions whenever we see something like that. Type. What else is important? Something called the parameter. Now, what's the parameter? The parameter of any shape whatsoever, the parameter of any shape whatsoever is the sum of the outer sides. What does that mean? It means just add the sides that are out as if you're doing a fence for the shape. So for example, if I have a weird shape that looks like this, the perimeter of this shape is those sides added, the outer ones only, and this arc, and this one, and this one. But we do not count the ones in the middle at all. So the perimeter is like a fence for the whole, again, shape. Somehow. Okay. Type, what else is important? It's the idea of the areas of shaded regions. So the idea of shaded regions is whenever you need to find the area of shaded region, you need to subtract things from each other. What do I mean by that? So you'll be given something like a circle, and then inside that circle, you're given the like a sector over here of a triangle of this one, and you're asked to find the area of this shaded region. So you can't really get the area of this shaded region unless you get the area of the whole circle. And you remove every white part. It's not shaded out. But instead of looking at it as a whole shape right together, look at it as a slice of a circle. So this is considered, this sector here, this entire part, the yellow part here, is considered quarter of a circle, ربع circle. Why? Because the circle has a total of 360, so 90 here, 90 here, and another 90 there. Four spaces like this. We will do the area of this circle divided by 4. That will give you the area of the entire yellow region. Then I'll remove from this area the area of the triangle that's shaded in red. And how do I get the area of this triangle? It's half times base times height. The base here is the radius, and the height here is the radius as well. So it's half times r times r. This is the area of the triangle. Whatever comes out now is the area of this shaded region. So I've removed from quarter of the circle, which is this sector, I've removed the triangle. What's left now is the shaded region up there, the small one. So if I know the value of the radius, I can easily get the answer. Those make sense. It's a sector, yes. لما يبقى slice كده من الcircle اسمها sector. Yeah, it doesn't have a name. It's just the shaded. طيب, this is برضه important قوي. So apparently if I need an area of anything inside of a circle, I definitely need the radius. So the radius is extremely important in the circle. Finally, since we discussed the circle has an equation. It goes like this: x minus h all to the power of 2 plus y minus k all to the power of 2 all equals to r to the power of 2. No. Okay, I'll tell you this part of the first. Actually, you reminded me of it, so give me a second, everyone. Before we start discussing the circle equation of the circle, we'll first discuss the area of a sector. So let's say we do have a circle like this one, and we do know that this is the sector we're discussing. Let's say we know that this angle is 100 degrees. We know that this length is 4, the radius is 4. We need to know the area of this sector. So how do I know the area of a sector? The area of a sector is mainly equivalent to the part of the angle. So الانجل الصغيره اللي هنا, which is this 100, over the full number of angles, which is how much? What's a full circle of angles? It's 360. So 100, this part over the whole circle, is equal to the area of the sector that I'm looking for, اللي هو part, over the area of the whole circle. So again, the part of the angle over the whole angle is equal to the part of the area over the whole area. That's how we get the areas of any sector. So in this case, you should put 100 over 360, and it should be equals to the area of a sector that I don't know, اللي هو wanted, over the area of the circle, which is pi 4 squared, اللي هي pi r squared. And then you cross multiply. So x will be equals to 100 times 16 pi over 360. That would get you the length of the area, sorry, of the sector. But what about if I need the length of the arc? What if I need just the length of this point? Same idea. برضو the angle over the whole angle is equal to the length of the part, which is the arc, over the length of the whole circle, which is the circumference, which is 2 pi 4, the whole r. This will still give me 100 over 360 equals x over 8 pi. And if I need to find the value of x, I'll cross multiply. So x here should be equals to 8 pi multiplied by 100 over 360. The red one will give you the length of the sector. The blue one will give you the area of the sector. Please ask if you're confused. It is easy now, sir. It makes sense at least. It's not like it's easy. It makes sense. That's what matters. طيب you don't understand ايه يا محمد؟ اسألني في point. قول لي فهمت ايه؟ او اقول لك قول لي فهمت انت ايه؟ فهمت الموضوع بيضايقني. لان والله لما بقول يا جماعه ask اقصد بيها this is actually the way you understand when you try to ask failing problem نفسها. Okay, what's the length? Length is mainly tool. What in a circle represents الطول بتاع السيركل كلها؟ السيركمفرنس ولا الاريا؟ اللي بيريبريزنت اللينث بتاع السيركل كلها، الحته اللي بره. جود. طب ايه اللي بيريبريزنت الاريا بتاعت السيركل كلها؟ الاريا اللي هي باي ار سكوير، صح؟ جود. بص الثابت ايه يا محمد؟ الثابت انها 100 اوفر 360 البارت بتاع الانجل اوفر الانجلز كلها. ايكوال بقى لو انا عايز لينث هيبقى اللي انا عايزه اللي هو اللينث اوفر السيركمفرنس كله لان ده اللينث. بس لو انا عايز اريا هيبقى اللي انا عايزه برضو اللي هو الاكس اوفر الاريا كلها اللي هي باي ار سكوير. So الفرق ما بين الاحمر والازرق ايه لو خدت بالك؟ It's just this part هنا. If you'd like to find an area then it will be angle over 360 equal area of sector over the area of the whole circle, which is pi r power 2. While if you'd like to find the length then برضو angle over 360 but now will be equals to length اللي انا عايزه over the circumference of the circle اللي هو 2 pi r. فاهم الفرق كده شويه ولا لا؟ بس هو ده الرول اللي احنا بنعمله. تمام كده؟ everyone؟ انا خدت وقت كتير قوي رغي وعايزكم بقى تحاولوا تجربوا شويه الحاجات اللي عملناها دي. ف if you actually have to Google Classroom select P1 geometry. هأجل شويه الإيكويشن اوف سيركل لحد ما اخلص شويه حاجات. دول فيهم كل حاجه. فيهم بارامترز، هنا فيها حاجات ليها علاقه بالبارامتر والاريا وبتاع. هنا فيهم ساينز وكوزاينز وتان اللي بسألهم. ده برضه بارامتر شيء يتقسم. هنا فيهم ارياز. هنا في تان وكده ومعاها بارت عايز سايدز وكده مينلي تانز. دول مينلي توتال اوف 5 questions. once we're done we'll explain them. والورك on P2 كمان لازم النهارده نحلهم. فيهم exterior فيهم areas فيهم parallelogram وده صايع شويه. دول 3 questions بس تانيين مش كتير يعني. So let's start with P1 geometry. Set the total of 5 questions, so I'll give you 8 minutes. And let's further go. Record. Again, we see a shape that consists of smaller shapes or a complicated shape, so we have to split it into smaller ones. And once we do that, we can easily see that there are two triangles and one big rectangle there. They say that x is less than 5. Use the figure above to find the set of real numbers if twice the area of triangle BME, let's highlight this one, twice the area of triangle BME added to, yeah, plus 2 times the area of triangle MEA is less than or equal to triple the area of rectangle ABCD. So I'll work on this part. I will try to translate this part step by step. First of all, let's start with the first part that says twice the area of BME. Where is triangle BME? It's this one. So what's twice the area of BME? What's the area of BME? Apparently it's a triangle, so it's half times its base, which is x, times its height, which is x plus 2. This is the area of BME, triangle BME. But they told me to find twice the area of that. Malu twice the area of to this is added to 2 times the area of triangle MEA. So triangle now MEA. What's the triangle of MEA? It's this other one. So let's use the red one for that. The area of this one would be half times the base, which is x, 5 minus x, times the height, which is x plus 2. And again, they told me 2 times the area of this, so all of this is multiplied by 2. Then what's wrong with all of those? They said that all of this is less than or equal, so all of this is either less than or equal to something, which is triple the area of rectangle ABCD. So what's the area of the triangle ABCD? It's length times width, which is in this case 5 times 2. Triple 5 times 2 means triple 10. Triple 10 is mainly 30, so all of this is less than or equals to 30. Now I have an inequality that must be solved to try and find the value of x. 2 times half, they'll cross each other. 2 times half, they'll cross each other, they'll become 1. So now I have this x to be distributed here, which will get me x squared plus 2x, and then plus these two brackets multiplied must be distributed this way. So 5 times x is just 5x. 5 times 2 is just 10. Then negative x times x is negative x squared. Negative x times 2 is negative 2x. And all of this is still less than or equals to 30. Now like terms together. So x squared and negative x squared will cross each other. Then I'll have negative 2x and positive 2x, which will cross each other as well. I'll just have left 5x plus 10 less than or equals to 30. Move the 10 to the other side, so 5x is less than or equals to 20 now, which means x is less than or equals to 4. This is all the set of real numbers that could work for x. No, there's one thing though. Now x is mainly the length of a side. So here x is just the length of this side. So how can a side have a negative length? It's impossible for a side to have a negative length. So that means that x must be from 0 until 4, but it can't be a negative number. So it can't be just less than 4 وخلاص. It must be from 0 to 4, which means that C is actually the correct answer, but not B. Please ask if you do have any questions about this one. So التايني trick اللي في الآخر is the fact that x cannot be equals to a negative number. So therefore you can't say that x is just less than 4 because this includes the negative numbers. Okay, so I was just
مستر والساين دي معناها ايه؟
الايه؟ Sign
Sign.
elements. X in x could be any number, any one number from 0 to 4.
هي دي الحتة اللي أنا جبتها غلط، يعني أنا جبت كله صح بعدين جيت عادي
This is called an element. So x is an element of the interval 0 to 4. يعني x ممكن تكون أي حاجة من 0 to 4. يا جاد البارت اللي انا بقوله يا حبيبي مش اكس هنا، هو بيقول لي ان في سايد هنا اللينث بتاعه اكس. لو انا قلت ان x is less than or equals to 4 دي يعني ده includes negative مثلا 100، ما دي تعتبر less than 4. while negative 100 في الحقيقة مش منطقية، لأن ما ينفعش يكون عندي side that's actually negative 100. It's impossible for a length to be in a negative. So this means that x could only be either 0 or positive numbers, but they must be still less than 4 or 4 itself. So the only option that says so is this C. Does that make sense شوية يا جد؟ Perfect. Now moving on to this. This is the one that uses the idea of the sine and the cosine that are equal. It says here that sine something is equal to cosine something else. What's the rule there? This rule, whenever I see it, I know for a fact that a plus b must be equals to 90. This is a must. هو قال لي إن ال a ب 2m minus 11, so I'll put that, plus b ب 5m plus 10, so I'll put that برضو. كل ده is still equals to 90. Add like terms, so I'll have 7m minus 1 equals to 90, which means that 7m is equals to 91, which means that m must be equals to 13. This is the value of m. Does this one make sense too? Perfect. Moving on to 16. Again, this is a shape that doesn't make sense to us, so we just need to split it into... Yes.
I didn't get the one that we just did.
Okay, tell me what parts didn't you understand?
And you said that a plus b equals 90. After that, that was good.
He gave me the a, so I put the value of a there. He gave me the b, so I put the value of b there. He told me that a is equals to this, and then they told me that b is equals to that, so I substituted instead of a and b. Now I just have an equation. So I added the like terms together, which are the 2m and the 5m, and they became 7m. Then added the negative 11 plus 10, which became negative 1. Then moved the negative 1 to the other side with addition, and then moved the 7 to the other side with division.
Oh,
Is this the part you're asking on?
yeah.
Perfect. This one, as I was just saying, we just need to split it into smaller ones. So when you split it like that, it's now a rectangle and a triangle. When you look at this side here, from this point here until this point, it's 3, which means that here as well, from this point until this point, it's also 3. If all of this is 6 and part of it here is 3, then this other part is 3 also. So that 3 plus 3 would be equals to 6. What are they asking me to find? They're asking me to find the length of x, which is this side. Now, if you look at this triangle, بقى عندي right triangle. Apparently, عندي this side, which is 5. عندي this side, which is 3. I'm missing the value of this. How do I find the length of this? Whenever you have two sides and one missing side, that's Pythagoras. And since the hypotenuse here is given, so I should do the 5 squared minus the other side squared and all under the square root. That should give me the length right away as 4. If this is 4, then this is as well 4. So this is the value of x, 4. Does that one make sense? All right, number 10. This one, you had a triangle. Inside of it, there is another triangle. You were told that this length over here altogether is 4. What is the area of the triangle MNJ, which is this one here? They need the triangle, the area of this. And I know that if I need to find the area, I need to find half times base times height. So when I look at the question, I do have the base, but I do not have the measure of the height. So that's what's missing now. Half times the base, which is 3, and I'm missing now the height, and I'll try to get it. Now, how do I get it? When you look at this big triangle, this huge triangle, you do have a side here that's 3. You do have another side here that's 4, which means I can get the hypotenuse, which is this side right here. Is that true? Oh, instead حتى of even that, let's actually read the rest of the question. If the area of the triangle MNG, the one that they want, is double the area of NJP. NJP is this here. Let me highlight it with yellow, sorry, blue. So they said that this area here of this MNG is supposed to be equals to double, yani 2 times the area of triangle NPJ. Here's how I'm going to think about this one, and I want you please to concentrate away with me. If the area of this part is twice the area of this one, then if this area has x, this area, the triangle here, has 2x, or the area of it is considered 2x. Is that true, or does that make sense? Yes or no? Yes or no? Do everyone understand the reason why? Because they said a triangle MNG is double the area of NGP, then if this is 2x, this should be x. Does that make sense to everyone? So the area of the whole shape is mainly 3x. What's the area of the whole shape? It's half times base, which is 3, times the height here, which is 4. This is the area of the whole triangle. So this means that 3x now is equals to 6, which means that x is equals to 2. So what's the area of MNJ? It's 2 multiplied by the x, which is 2. That would give me 4 centimeters squared. So the area, so the answer in this case is C. Would you? Yes, please ask. Ask يا محمد. ايه لحد فين فهمت يعني؟ Yes. Why did you say the area is equal to 3x? Because if this MNG part is 2x and this part NPG is x, then the whole thing is x with and 2x, which is 3x. صح? So if the whole triangle area بتاعته is 3x, how do I find x? I have the measure of this base and I have the measure of this height. So I got the actual area, which is 6. And I said in the 6 دي المفروض تبقى equivalent to 3x. That would get me the area of one triangle or one x منهم اللي هي triangle NGP. I know now that this is 2 وعارف ان MNJ هو الدبل بتاعه يعني 2 times 2 يعني 4. مش قوي؟ صح؟ Are you sure؟ طيب علي ولينا وهيثم. Perfect. So this one is tricky, did not really use any rules of areas except for the area of the whole bigger triangle, did not focus on each part separately. Number 14, on the other hand, you're given still a triangle. Inside of a triangle, you're told that AB is equals to 7. So this part here is 7. You're told that DC is 13. This entire side here is 13. You're told that tan, the angle C, is equals to 2 root 6 over 13. Where is the angle C? It's this one. What is the tan supposed to be? It's supposed to be opposite over adjacent. What does that then mean? It means that the opposite to angle C is 2 root 6. So what's opposite to angle C? It's AD, this one. This one is 2 root 6. While the hypotenuse is at the A, sorry, the adjacent is at the A is the 13, which is fair on this side, lower 13. Can I get, or using these two sides, can I get the measure of AC? Actually, don't need أصلا the measure of AC حتى. Using these two sides, this one and that one, can you get the measure of BD? Yes, because we do have a right triangle here and we do have two sides. Yes, we did. So we'll say that 7 to the power of 2 minus the other side, which is 2 root 6 all to the power of 2, is supposed to give me the measure of dB. 7 power 2 is 49 minus 4 times 6 يعني 49 minus 24 يعني 25 25 صح ولا حسبتها غلط؟ Yes, now square root the 25 is mainly 5. So the length of DB here is 5. If DB is 5 and the whole DC is 13, what's the measure of BC only? I'll remove from the 13 ال 5 اللي في الأول, and that should get me 8 as the correct answer. Does this one make sense? Good. كده أنا I took too much time بصراحة ومفيش time وقت الحل اللي فيهم التانيين. So here's what will happen. You guys will have to solve P2 as the homework for it today. Why is it? Okay. Nothing is happening.